Hello, welcome back to Cracking the Cryptic. And well, what happened with yesterday's video? It was so strange. I didn't even know it had happened. When I edited the video, I'm afraid I didn't watch the whole thing through. It's an hour and 45 minutes. And I did not find out that after about 45 minutes, my face froze. Well, what happened was obviously the camera stopped working. And it just kept this frozen image of me looking a bit puzzled, which was pretty appropriate for a puzzle that took me 99 minutes plus to solve, but certainly not the quality we aspire to. I mean, I'm really hoping that that is a new type of technical difficulty, a glitch with a peripheral that hasn't happened before and won't happen again. And I apologise for what did happen, but there we go. It annoyingly then affected the connections and Wordle videos that I filmed afterwards, which I still didn't know. The camera had its light on. I didn't know it wasn't working. Very disappointing. There we go. So if you watch my Wordle in a minute that was posted today, that's a very face-frozen Wordle in a minute. But actually, the good thing is you can still hear the commentary and you can still see the puzzle being solved. And those are the important things. It turns out my face is not important, which I have always known. But anyway, there was the confirmation. So let's hope that doesn't happen today. Let's hope we can enjoy today's puzzle, which is, well, it's by Acheros and it's a debut. The puzzle Acheros sent us would not have featured on the channel, apparently, but the tester, who is a very good setter in his own right, removed some givens, and there are none left, removed the givens, I suppose, and this puzzle is good. Well, I mean, it was good before, but it wasn't hard enough. Now it is, and I'm terrified it's going to be too hard, but we'll see. So it's called Hunt the Prime. It's got prime numbers in it. We will look at that in a moment. I'm first of all going to tell you that we will be delighted on the 1st of August to bring you a new Sudoku hunt on Patreon. Do join us on Patreon. There's always, well, connections videos, one of which will feature a frozen face when it comes out in a few days' time, for a little bit of it only. Crossword videos once a month at least, and often more, and all sorts of content. So we'd love it if you'd join us on Patreon. We'd love it if you'd try our apps. They are brilliant. They feature Arrow Sudoku as a standalone. And Fog of War is the latest that you can get via the CTC app, as are the Worms by James Sinclair and Marty Sears. They are brilliant too. Do check them out on the links for the apps. There's also SVEN'S SUDOKU PAD, which you can support, marvellous software that we use every day. But that is enough waffle. The first link under the video is to Hunt the Prime by Acheros. The rules are as follows. Normal Sudoku rules apply. That is a huge relief. I haven't had a normal Sudoku rules apply for the last 2 days, and it's been getting worse and worse. I'm really pleased to be going back to that. So 1 to 9 in every row, every column, and every 3 by 3 box. Highlighted cells, that's the blue ones, contain only prime numbers. Now the Sudoku prime numbers are 2, 3, 5, and 7. 1 does not count. Mathematicians will verify that. And numbers along an arrow sum to the numbers in the circle. So those two add up to that one. Give it a try on that link. You can check the video length to see how I found it. I'm going to restart the puzzle on my clock now. Let's get cracking. Okay, well, some of these blue cells form quads in rows, columns, and boxes. So row 4 has got each of 2, 3, 5, 7 in a blue cell somewhere. Column 4 and column 6, the same. And by writing in those numbers, we found a quad in box 5 as well. Is it worth treating this as a colouring puzzle for primes and non-primes? I'm going to start that way anyway. These yellows are the non-primes. They're 1, 4, 6, 8, 9 in the central box. And I suppose in column 6, column 4, row 4, and row 6, we can do the same markings up. I mean, I suppose, obviously, I could go round all the blues, making them 2, 3, 5 or 7. This one is a circle, so that's not going to, well, it's got a 3-cell arrow. So actually, I think I can rule out 6, because if this was a 1, 2, 3 triple, wouldn't there have to be 2 blues in it? Yes, correct. Because the blues are all, yeah, there wouldn't be 2 yellows, that's the point. This is another arrow circle, which we have coloured. Oh, this is an interesting one. So the arrows from here, obviously there's that one in box 1. There's one that goes to here in 2 cells, and there's one that goes to here in 3 cells. Now there's a relationship to be deduced there. And that is that if the sum of those 2 is the same as the sum of those 3, then that one is the sum of those 2. So this is not a 1. It could be a 4. I'm not going to rule anything else out. This is not a 9. These 2 add up to that one. This is not a 9 or an 8. This one is the sum of 3 cells in the box. This time it could be a 6, because that could be 1, 2, 3. Indeed, that would have to be a 2, and that would be a 4 in that case. So I'm not ruling out 6 from there. This is an arrow in a circle. This is the most helpful one. I hadn't seen this. Because 8 and 9 are not options for the blue cell that we're in here. 2 and 3 are impossible. I'm going to say 3 is clearly impossible because there are 4 cells lower than this circle in the box. Now, if that was a 5, these would be 1, 2... No, if this is a 4-cell arrow, that's not a 5, that's a 7. In fact, that is maximum for that circle, and then we go minimum on this arrow. It's got to be a 1 there, and a 1, 2, 3, and that means we get another blue cell. We've got a 2, 3 pair in this box. We know this is yellow. That's 1 of each. We can't fill those in. 7 there. This is not a 7. That's 2, 3 or 5 going with 5, 2 or 4. This one, well, this can't be 8 or 9. It also can't be 6 because we can't put 1 there. So 3 or 6 there. Maybe one of these is impossible. I can't see why, if so. And of course, by the same sort of method, that can't be 7 just by Sudoku, but this can't be 7 because it's on a 3-cell arrow, adding up to no more than 9. Now, what next? This can't be 9 or 8 because it's going with a minimum of 2 there. Oh, we've got this one as well. Yes, obviously these can't be 9 or 8, and that can't be 7. I really should do this stuff. Okay, there I don't know. There's a lot of possibilities. Down here, this can't be 9 or 8 because this is a minimum of 2. This can't... I was going to say it can't be 2. That's not right. This can't be... Oh, this 1 sees quite a few yellow cells. That can't be 1. This 7 sees that, which is blue, and was 5 or 7. So we're going to get a 7 somewhere down here now. We're going to get a 1, not in the circle, not by any means, in one of those 2. These can't be 7 now. Yeah, there's Sudoku ramifications of everything. That can't be 5 because of the Sudoku. Now we've got a 2, 3 pair. Right, the other odd digit in this column is a 7 in one of those cells. So that's not a 7. One of these 2 is a 7. It feels unlikely to be here. If it was here, that would be 7, 1, and 8. 8 would need a 1 here. 1, 3, 4. Ah, it is possible. Okay, what next? I'm liking this. This is very interesting. That didn't quite become a 2, 3, 5 triple. This is a 2, 3, 5 triple. Is that useful? No, probably not. 5 is looking at that cell. If that was a 5-2 pair, that digit would be 3. That's less interesting than I thought. What if it was a 3-4 pair? That would be 1. This would be 6. That would be 1. 3, 4, 1. Certainly seems possible. Okay, what else can we do? This one is 4, 6, 8 or 9. I mean, I don't really see the point of pencil marking that, but somehow my fingers have done it without my actual bidding them so to do. This can't be 6 because those two add up to at least. Oh, that's a 1-4 pair in the box. That's interesting. Ah, well that might have ramifications. Okay, if this was, what, a 3-4 pair? Yeah, that's interesting then. If that's a 3-4 pair, this has to be 1. That becomes a 4. This is a 2-3 pair. And, yes, okay. Remember that these two have to add up to that. 4 plus 2 equals 6. That would be 3. Okay, it does just work. Okay, what about the other situation? If this is a 5-2 pair, that's 3. This has to be 1 to add up to a 4 there. That's interesting. 3. What am I saying? 5-2 there, 3 here. That's a 1. And then you've got 4 there and 4 there. These are 4s. Is that all right? That would become a 6. Oh, that's quite big. Can't quite see anything that resolves that one way or the other at the moment. This arrow, I'm not bothering with that yet. This one seems out of it. This one can't have a 9 on the arrow. Could that be an 8? This would be a 1. That would be 9. Yeah, I can't rule that out. Okay, let's think about this conflagration of arrows up here. If that's a 5, that's a 1, that's a 6. This becomes 4. Okay, this can't be 5. That's good. Because that becomes a 1, this becomes a 4, that makes this a 3, and this has no possible fill. It sees a 5 and a 3. So that's not a 5. That is 2 or 3. What about this one? If this is a 5, that digit is a 1 again. This is a 4. That's a 3. So if this is a 5, that's a 3. This isn't quite as powerful. Of course, if that's a 5, this has to be 4 and that circle is 9. And these are a 1-3 pair. 9, 4, 3, 5, 2. Okay, that all works. So I can't get away with anything there. I don't know. Let me just think about this again. There's something funny going on here. If that's a 4-3 pair, this one's a 1, so that digit becomes 4. And then this has to be a 2-3 pair with a 9 circle. So we would definitely get 4, 3, 1, 2, 9 here. And this box would have 1, 2, 9, 4, 3. 4 and 3 would be in those cells. I don't know, it looks quite... 6 or 7 would have to be in that pair to get to the total. Now, I can't rule it out. Oh, I can see that 7 is in one of those 2 cells in box 4. That's just Sudoku, effectively, because of this thing and the pencil marking here. Could that be 7? Oh, if not, we get a 7 X-wing. If that was 7, this would be 2, and that would be 9. And they'd both be prime. Interesting, but not immense. Oh, goodness. Okay, I don't really know where to go. This is quite a tough puzzle, actually. The 2-3 pair. Only one of them goes here. Okay, think about whether this can be a 5 again, because I thought that was unlikely. If that's a 5, you've got 4, 3, 1. So you then have 5 and 1 in this row along with a 9. 1, 9, 5. Yeah, I don't know. That seems all right to me. Okay, I'm going to have to go somewhere else. That's quite annoying because I don't know where else I can be looking in this. 1, 7... Oh, there's a 1 in one of those cells and a 1 in one of those cells, therefore. If it wasn't here, oh, that would be ridiculous. If it wasn't here, that would be a 4-6 pair on this arrow, so it's obviously here. That's blindingly clear. Right, so this is either a 2-6 pair, making that a 9, or a 3-4 pair, making that an 8. Those are very distinct possibilities. This is now, it's always been a 2-3-5 triple. That's not interesting. Ah. I don't know. Right. If this is a 1, it's very prescriptive. That has to be a 6. And that's a 4. And this is a 2-3 pair. In fact, we know the order. Oh, that's interesting. So if this is a 1, is that what I said at the beginning? I don't even know. If this is a 1, that's 4 and 2 in that order to make that into a 6. And this must be 3 and that must be 9. If this is a 4, then we've got a 3 here, a 5-2 pair, a 3 there. So if this is a 4, we've got 1, 3, and then this is 2 or 5, leading to 6 or 9. Have I just ruled out 8 from ever being here? Can that be a 5? 1, 2, 5, 8. Yeah, hang on. If this was a 2, yeah, this can never be a 5. Oh, hang on. I haven't thought about 1, 3, 5. It can never be... Okay, this can never be 8. That much I'm going to say. I'm going to assert this loudly. Because if it was an 8, this trio would have to be 1, 2, 5. It can't be 1, 3, 4. And with a 1 there and a 2 there, you'd have a 4 here. And this cell would have no fill. So that is not an 8. The 8 in this row, in row 4, is now in one of those 2 cells. And these can't have an 8 in. Which isn't surprising. It isn't huge, but it is progress of a very limited sort. Now, if this was a 1, that would be 4. This would have to be 9. And that would be a 6-8 pair. If it's not 1, if this is 4, what's happening here? 4 and 5. Wow, and then this would be 6. Right, if that's a 4, which I'm thinking a bit unlikely at the moment, that's a 5, so we can get to a 9 total. That becomes 6. That gives us 4 and 2 there. That's a 3. Do you know what? I think that does work, so it's probably going to be right. 4 there surprisingly does seem to work. Okay, I have to go a bit more carefully and slowly through the noise and haste. What do we do? I don't know what I'm meant to be looking at, really. I'm getting mighty confused now. Okay, can this be a 7? This would have to be a 1. That would give us 4 and a 2-3 pair here. If this was 7, this would be 1. That would be 1. This would be 6. If that was 7, that would be 1 and this would be 4. This would then be a 4-2 adding up to the 6 here. So this would be 6. And there would be nowhere left for 6 in this box. Isn't that weird? Right, I'm going to explain that. If this was a 7, this would be 1. That would be 4. This would be 9. No 6th in those cells. The fact that 4 was there, remember these two add up to that, would force this to be 6. No 6 in these cells. And the fact that 4's there makes that 1 and that 6, no 6 in that cell. There'd be nowhere for 6 in this box if that's a 7. That is a weird conclusion, but this is 7 now. That gives me 7 in box 4, which gives me a tiny bit of colouring to do. And that almost makes me feel like I've just achieved something. This digit is 6, 8, or 9. I got the 7 in box 5. That's not 7 now. I have a feeling that's not going to do a lot else. Oh, 2, 3, 5 triple, that's a 7. It did something else, okay. Good. Now, what else can we do next? Still got all these possibilities of those two adding, being 1 and 3 adding to 4, or 4 and 2 adding to 6 here. It's so strange how they interact with each other. It really is. Right, I want something else achieved. Let's have a look at this pair again. Maybe the options have narrowed a tiny bit up here. If that is, let's try 3, 4, because that forces 1 and 2 and 4 and 3 and 6. Well, that doesn't work, because again, where can you put 6 here? If that is 3, 4, that's a 1, that's a 4, and that's already too big to stop that being 6. That being 1 makes that 6, and none of these can be 6. So that is not 3, 4. That is a 5, 2 pair. I can colour the 2. Oh, I could have coloured that one a long time ago. Didn't do it. Now, 5, 2 there makes this a 3. Is that going to do anything? I have a feeling it's not. Oh, we've got a 5 down here along with the 7. That one can't be a 7 anymore. This is still not done. That's so weird. Right, 3 there means that's not a 3. What does it mean for these? They could still go 1, 6, 2. No, no, they couldn't. 3 can't go. These 2 add up to that. So that's a 1. And that's a 4. Well, they could, but at least I know all that. Now, this is either a 6-2 or a 9-5 pair. Oh, that's become a 4. That's a 3. That doesn't seem to do anything. Takes 4 out of a few cells. We're down to 2 possibilities over here. One of these has to be 8 and the other one has to be 4. Is that right? Yes, by Sudoku. 4, 4, one of them is a 4. And in this row, one of them is an 8. Ah, well, that's quite handy. 4, 8 pair. This digit is now a 6, and that is going to help, I think. This can't be 5, obviously. It doesn't help that much, does it? 6 there, though, makes a 9 in the circle, which I was always expecting. Now we can add up this arrow, and that's a 5. And this is not a 5, and that's a 5. And this is 2, and this is 3. And there's lots of the primes going in now. If at some point during the filming of this video I have used the word odds to refer to primes, now is the time that I apologise. Right, these digits are all yellow. 4, 6, 8, 9. That one is 6 or 8. On this 9 arrow that we now know to be 9, this digit sees 1, 2, 3, 4, 5. So that's quite high. 6, 7 or 8, that makes this 1, 2 or 3, but look, it can't be 3 or 1, so we suddenly get these. 2 and 7, they're both prime. So much blue going on. Right, those are the last primes for column 2, the last primes for column 3. That 7 is looking at this thing, 2 is looking at both of those. Now is finally time to look at this arrow properly. Maybe. If that's an 8, this is 1, 3 or 5. If that's a 9, it's 2, 4 or 6. Well, not 2, but that's really annoying. I mean, it did nothing. It did nothing at all. There's a 2, 3 pair. So this is 5. And this isn't at the top. Okay. This can still, this hasn't changed. I can't believe that this has so many options. What about this arrow? What can this circle be? Because it can hardly be odd. 1, 3, 5, 7 are ruled out. So if it's odd, it's a 9. If it's even, well, let's put in all the possibilities. I think even 2 is a possibility. They could both be 1s. So let's not forget that. It's unlikely, but you never know. Oh, those don't have a 9 in. That's just Sudoku. This is a 4-9 pair. What about these? They're from 1, 6, 8. Sorry, I should do the Sudoku before I move on. None of these can be 4 or 6. Gosh, they're a 1, 8, 9 triple. That's not 6. I really did miss a bunch of Sudoku, didn't I? That's not 4. That one's not 4. Oh, look, I have 8, 9 pair in this column, so that's 4 or 6. Okay, now I was going to look at this arrow. It doesn't feel all that helpful. If that's a 6, this is going to be a 2. It can't be a 3, and that's an 8. So 6, 2, 8 is one possibility, and the only possibility if this is a 6. Now, if it's a 1, there's only one possibility if it's a 1, because where does 1 go in this column? If that's a 1, that's a 1. So then they add up to 2. So this is either 1 or 2, and this is either 2 or 8. That's weird. And one of these is a 2 in the row. Is that interesting? Not really, annoyingly. One of these is a 3. I can see that by Sudoku. Now this sees all the blue digits, so it's yellow. 6, 2, 8, or 1, 1, 2. That's so strange that both of those are perfectly viable possibilities. This can't be 3 anymore. Okay, I'm going to have to think about this a little bit because there are ramifications. If I don't know, if that was odd, this is 6, 4 or 2. If that's 9, this is 6 or 4 because it can't be 2. If that's 8, oh, if that's 8, that can't be 5, by the way. I've only just seen that, you numpty. Right, well, this is a bit more restricted. Okay, so 9 going with 3 gives a 6. 9 going with 7 gives a 2. 8 going with 7 gives a 1. 8 going with 3 gives a 4. It can't be 2. So this is 1, 4 or 6. Okay, what does that mean? Seven in this row, by the way, is very limited, either there or there. If 7 is not here, this is a 3 going with a 6. That would have to be 3, 6, 9, 7. Oh, hang on. Just wondering about this digit. If this is 4, that's an 8 and this is not 4. So if that's 4, where does the 4 go in row 3? I can tell you it doesn't go here because there's a 4-9 pair. It must go here. If that's a 4, this is a 4. Okay, it looks like that's all right. Okay, I haven't really thought about this arrow at all. I mean, it's difficult because there's nothing to really consider about it, I don't think. This row, 7, 3, 4, 2 and 5 are both over here somewhere. If that was 2 or 5, we'd have a pair, we'd have 8 here. That would be 2, and then this would be 5, and that would be 2. So this can never be 5, this digit. Because that would be 2, that would be 8, that would be 2, that couldn't fill. So one of these two is a 5. Pity that's not an X-wing. I'll tell you what, these two can't both be 2 either, or they'd kill the places for 2 in box 9. So one of those is a 5. And that also means that digit can't be 5, but it also means that these two can't be 5, because at least one of these is a 5. So the 5 in this column is either there or there. Another thrilling bit of information. Oh, goodness. How... Okay, if that's a 2... Oh, I could colour these against each other. I don't think there's going to be a lot of point. Red, green. I'm just looking at columns 4 and 6 to colour the 2s and 3s against each other. Oh. That's fairly ugly colouring. Let's. But we knew these were different because of the parity. Actually, the parity of the other digits on this line, apart from that, is even. The parity of the other digits on this line is odd. So they're adding up to the same total. So those are always going to be different parity. I mean, fascinating, true. Not very helpful. Yeah, I don't know. I'm feeling very stuck now. I need to think of something that's going to help. Half an hour in, and I don't really get what to do. There probably is something. Let's think about this box a bit more. We've got a 4-8 pair there. 4, 8, 7, 3. These 2 digits are in those cells, but 2 and 5 are also in these with 1 of 169. Is 211 less likely than 826? Actually, 826 forces a few more things. Oh, if that is an 8, that's an 8, and then we've got 8 in one of these cells. That feels quite interesting, but I don't know why. Okay, I'm going back here and thinking about 7 again. That makes this 3, 6, 9, 2, 5. We've got 1, 4, 8 left. That would have to be 8. That would have to be 1, and that would have to be 4. If that's a 7, we know we know everything in the row. Literally everything in the row if that's 7. Let me just fill in what those are in corner marks. 7, 1, 8. This would not be a 7. I'm going to take out those corner marks. This would be a 6. Hang on, this isn't what I was doing a moment ago. 6, 7, 1, 8, 6, 2, 5. That has to be a 3 because it sees the 4, 9 pair. Now I'm confused. Was this not what I was doing? Was I thinking about a 3 there? This can never be a 4, by the way. I've only just seen that. That's so bizarre that I mean, at some point, maybe it could have been a 4, but that's long gone. Right, maybe I was thinking about 3, 6, 9 instead. 7, 1, 8, 5, 2, 6, 3, and then these could be 4 or 9. If it's 3, 6, 9, that's 5, 2. This has to be 8 over here, because it will see a 4 in the box, in the pair. 3, 6, 9, 5, 2, 8. That would be 1. This would be 4, definite, and that would be 7. And that's if this goes 3, 6, 9. So we're down to these corner marked possibilities for all of these cells. And I wish I knew what I was thinking about here, because I don't really know what I'm meant to be considering. Okay, if that was 1, 2, 6 and a 9, we'd have a 6, 9 pair here. 8 there, 4 there. 6, 9 pair here makes that an 8. That makes that an 8, and that an 8, and that an 8. We get all of those 8s firing up. I can't quite see what's going on. I'm so sorry. Something is doable at this point. I really feel that. I'm literally going to pencil mark this as 4, 6, 8 or 9. I'm just wondering about this column now. 3 there. The 7 in the column is either at the top or the bottom. That's a bit weird. It's not enough. It's not enough. 4, 9 pair there. Okay, there's something quite interesting there. If this was a 4, that's 2 and 6, and that's a 9. So you'd have 9s there and there. The third 9 in the 3 rows would have to go there, definitely. Then you'd get the 9 in row 6. Oh, it's almost powerful, but not quite. And where would 4s end up? That would be a 4. don't know. Something is going to fall out here, but I have to spot it. That's really tough. Right, if this is 963, the only place for 7 in the row, and I hope I keep saying that, is here. In row 3. That would be the only place for 7 if it's not there. 963 would lead us 7 to be here. So this would be 5, 7, 9, 1, 2, 6. It would have to go 8, 4, 3 across the top. Oh, it's so close to yielding something. And we don't need much more. We need a couple more digits in the puzzle and it's gonna fold like a cheap suit. I don't really mean that. Okay, what if this is an 8 and that's 2 and 6? This is a 5 then. If that's an 8, this is 4, 3. Oh, 1, 2 in the column. I just don't know. I don't know. I feel like I do know and I don't know. Okay, let's think again about the ramifications of 1, 3, 4, because that makes that an 8. And then we've got 8, 1, 7, 6, 2, 5. Oh, if that's 1, 3, 4, that has to be a 9. Yeah, 3, 9, 4. Now, where are the problems with that? That becomes a 6. That's a 6. Ooh. Oh, there might be a problem with that. That's quite an exciting one. Right. I think I might be onto something this time. I might not pan out, but it's about 6s in box 7, if you would believe it. So if that's 1, 3, 4, this is 8. 8 goes with 1, 7 here. No, I'm wrong. Oh, that's so annoying. That makes that a 6, and that's fine for a 6 in this box. I thought I was going to force that and that to be a 6 together, but that is not how it goes. No, if this is 1, 2, 6, 9, that's an 8. Oh, blast. Oh, does anybody know any ruder swear words that I could use? I'm joking. I don't. No jokes. I don't want ruder swear words. I want better insight. That would help. This box is painfully unmarked. Right, that is 4 or 9. This is basically what I worked out earlier. These corner marks were the only possibilities. In fact, that can't be an 8 according to my corner marks. Let's just figure that out. Either this is 817 and it can't be an 8, or this is 963, that's 7, and that has to be 8. So this is never 8. And I think these corner marks are right. That's 3 or 8. This is 4, 7 or 9. That is an annoying group that I wish I didn't have to fully pencil mark. But that is only 4 or 9, and they are quite a restricted pair. Are we meant to really consider what's going in here? Maybe we are, and that is worth thinking about. So, how to think about that exactly? What if this was a 2? Right. If this was a 2, this is an 8 and that's a 2. And then this has to be the other 2. I haven't thought about this before. So if this is a 2, We've got 2s here and here. We've got an 8 there. I'll tell you what that gives us is an 8 in one of these cells. Okay, this could get interesting. If that's a 2, this is a 3-4 pair, that's 8, and this is 1-7. So we'd have used up 2 1-7. For me to put an 8 in one of these cells, it can't be there because we've used up 2. Sorry, it can't be there because we've used up 1 in the region. So it would have to be there. And its sum, couldn't use 2 or 1, it would have to be a 3-5 pair. So if that's a 2, this is 1-7, we must have a 3-5 pair and 8 in the corner. Well, do you know what? All I'm going to find out from this, even if I follow this chain through, is that that's a 5, and that's not actually going to help me advance. So I'm going to stop thinking about that, because I don't think it's actually... It might work, but I don't think it's helpful. I'm going to remove all the corner marks from that row, because these are basically candidate marks. Now we figured out the possibilities in this row. 8 is either there or there in the column. Okay, if that's an 8, this is a 3. And this is 7, 1, 8. Wow, I don't know. I'm so sorry. I'm really struggling with this. I was going to call it this nonsense. I mean, it's nonsense in my brain. I don't mean to denigrate the puzzle at all, which is really excellent. But I'm not seeing the way to do it. And I think there is a way to do it, and I'm just not seeing it. So, okay, let's go back to this. If this was 2, 1, 7, that has to be 3, 5, 8. These digits are 4, 6, 9. That gives me a 4, 6, 9 triple here. And the 8 in this row would have to be there. And that would be 8. And this is all based on that being 8. Ooh. And did I say that would be 8 in this scenario? I can't remember. Yes, I did, because we were starting with a 2 there, which makes that 8. And now 8 has to be, oh, well, we said it was in the corner, and it's there. Oh! Oh, bother. It does all work. Is there some other fallout from that? This would be 9. That makes that 9 just de facto. It's the only place for 9 in row 6. If this is 9, that's 9. Does that do anything? Not really, seems to be the answer. No, I don't think it does. That's incredibly annoying as well. Okay, say that's not 2. I mean, the trouble is, say that's not 1, 7. Say that's 6, 3, and they can't go in this corner. That's a 9. And this is 6, 2. So if that's a 6, that's a 6. That's quite an interesting collocation. I'm marking places for 6s now, and not very successfully, if I'm honest. It just doesn't yield enough. It doesn't tell me anything. Well, that would end up being an 8, so that one would be the 6, this one here. It's got to be all about this arrow somehow. It's got to be. 2, 1, 1. 2, 1, 1 looks very viable. 8, 2, 6 looks less so. If that's an 8, that 6 forces that to be an 8. And that's an 8. And I think we've worked out it can't be, I'm not sure if I worked out it can't be here under any circumstances. Maybe I did. Oh, I'm still really irritated about row 3. The more I look at that, the more I feel it's got something going on in it. But I can't see what. I admit it, I cannot see what it's got going on. I think there is something, and I don't know what it is, and it irritates me. Oh, goodness me. If that's... Well, this is a 1-6 pair. I haven't even seen that. Okay, so if that's 6, we've got 8 here and 1 here. Does that do anything together? Very unlikely that it does, but let's think about it. It makes that a 1. That's not doing anything interesting. Well, it's keeping 1 off here, that's all. No, that is not doing anything new or interesting. If that's an 8, that's a 7, because this is 7, and then we need a 7 in row 1, and it has to be there. One, 7. Oh, it's driving me crazy now. Seven, 2, 4, 9, 1. Four there makes that a 4. And then this would be 4, 1, 7. We'd still be in the world where 3, 5, 8 works here. 4, 1, 7 there. 9, 6, 8, 3 over there. It's so strange that these possibilities can coexist. There are 2 really different possibilities, and they just seem to be open and alive, and I can't work it out. I literally cannot work it out. Goodness gracious, I'm so sorry. Right, 4. If that's a 4, that's not a 4. In fact, oh, that's, okay, if that's a 4, that's 6, that's 8. Okay, I haven't thought about that. If that's a 4, that's 6, that's 8. This is a 1-6 pair, that's 3, 5, 8. And if that's a 4, that's a 3. So this would be 5 or 8, and that would be 9. 4, 3, 1, 9, 7. 5 or 8 here. All of these are from 2, 5, 6, 8. Nah, it's not quite enough. It's so very nearly enough to do something with. It's not quite enough. Ah, driving myself mad at this point. If that's an 8, this goes 2, 1, 1. And that is a 6 or a 9 at that point. I don't know what that proves. I just don't know what that proves. 3 and 5 are up here somewhere. Well, 5 is definitely in one of those 2 cells. There's something going on with this. Maybe there's just digits that can't appear on it, and it's obvious and I can't see why. Maybe there's more than one of those. That's not impossible. That is not an impossible thought. If that was 2, that would be 2. And that would be 2. Yeah, that's what gets 8 onto this, isn't it? If this is 2, that's 8, that's 8. 8's one of those. This can never have a 1, sorry, it can never have an 8 on one of those cells, because it would be 1, 8, 9, that would be 4, but this would be 6, so that would be 9 as well as that. Oh no, hang on, that's not what I'm saying. 1, 8, 9, 4, 6, 3, actually, sorry, check that. 7 there and a 2, 5 pair. Well, it would fail for a weird reason. 1, 8, 9 here makes that a 6, 3 arrow leading to a 9. But because 7 has to go there, 2 and 5 are here, and that's a 3, 4 arrow leading to an 8 instead of a 9. So 8 never goes in those cells. That's what I've finally learned, and it's been a hard lesson. So 8 goes in one of those in the box. So does, oh no, I was going to say so does 9, but of course 9 could sit here. I do think this is going to be 8, 3, 5 now, because so many roads lead to that conclusion. And this will be a 4, 6, 9 triple. I think that's going to happen, but I mean, this is not the way to deduce it. Oh, here's a thought. If this is a 9, that's a 9, and that's a 9. And then 9 has to be in one of those two cells, and definitely there. We've obviously got 9 there. Ah, that does not work. Right. I think I'm about to say this is not a 9. No, I'm going to say this is not a 9, because the 9 in box 2 is there. The 9 in row 2 is definitely there. The 9 in box 6 has to be in one of those two cells, and now there's nowhere for 9 in box 5. Wow! Well, that's fine. This can't be 9. That is a 4. Please do something to help, Mr. 4. Please help me. Although I have a feeling you're not going to. Getting a 9 here is probably not going to solve this puzzle. Getting a 4 here also probably doesn't. Because the 9 there limits 9s a bit. The 4 there limits 4s to 2 positions here. That is not what I wanted. I wanted 4 to be more limited than that. So I should stop complaining, I know that, and just try and use these new digits, because they are something powerful. 9 in this box is now in one of those 3. What about column 8 for 9? No. Okay, come on, we got something done. I'm so pleased to get something done. If that was 7, that would have to be 2 and 9. No, I don't know. That's all right. Oh, goodness gracious. How can finding that was 9 and 4 not solve this? Maybe there's more I could do with that theory about 9s. So is it true that if that's a 9, we've got this problem all over again? No, because now 9 can't be in any of these cells. It's a different story now. Either 9 is in what? Well, can 9 be here really? 9 there is going with 8, 1, 7, 6, 3, 4. Then it's 6, 2, and that's a 5. So 9, 7, 1 goes with 5. Then the digits I have left for the corner are 2, 3, 4, 6, 8. Well, we can rule out 3 as the only odd. It's got to be 2 plus 6 equals 8. Or 2 plus 4 equals 6, sorry. Three would have to be there. Okay, that's interesting. So if this, is this based on this not being 3? No, it was based on that being 9, which is a slightly different story. Let's say that's not 3. I wonder if I can prove that 3's, I doubt it, but let's say this isn't 3. 7, 1, 8, 1, 3, 4 there. Oh, well, this is quite the opposite. If that's not 3, that is a 3. And then 3 in box 1 is box 3 rather is confined to those two positions. That's interesting. That's interesting. Could it be 3 in the corner? I doubt it very much. Right, let's work that out. So if that's not 3, we've got 7, 1, 8, 3, 4. 3's in one of these two cells, and we've got a 1 there. So this can't be 3 in the corner. Right, if 3's not there, it's there. It's in one of these two cells in the box. That's so strange. Let's just before, well, okay, that gets me 3 out of this cell and puts it into this cell. So we get a 3 here. This is now 4, 6, 8 or 9. And that 3 is not going to do anything on its own because it just looks back up at these. So let's think again about this not being 3. Then we're going 7, 1, 8. We're getting a 3 here, definite. 3 can't add to 1. 7, 1, 3. Oh, and this pair has become 4, 3. 7, 9, 1, 4, 3. So these are selecting from 2, 5, 6, 8. And that's a 3. Can't be 3, 2, 5. That would break this. Could be 3, 6, 9. What are we selecting from? I can't do it in my head anymore. I'm losing my reason now. Let's think about this being a 3. Then green is 3. That's just colouring. 7, 1, 8, 4. Oh, that 4's going to make that a 4. Right, hang on a second. If that's a 3, we've got 7, 1 here. That's a 4. By Sudoku, that's going to be a 4. So if that's a 3, this goes 1, 7, 4. Then we've got 2, 5, 6, 8, 9 left. That can't be a 2. 2, 5 would break that cell. This could be a 5 or a 6 leading to an 8 or a 9 in the corner. Got 1, 7, 4 here, 3 there. 9 has to be in the top rank. 7, 4, 8, that's a 9. 6, 3, oh, come on, do something more. You're nearly doing enough. You're nearly doing enough, puzzle. If that's a 3, this is 1, 7, 4. And this is either 6, 8 or, 6, 9 or 5, 8 at the side. Two would have to be in one of those cells. And we know 2's in one of those cells. So that would be a 2. And that would have to be a 5. There's a lot of ramifications to think about here. It's really interesting. What is going on though? I can't quite get at the nub of this. Something is nearly yielding here. tell you something I haven't thought much about. If that's a 1, then the 1 in row 6 is in one of those cells. Maybe that doesn't do anything at all. Okay, if that's not a 1, if the central digit is a 1, then one of these is a 1, one of those is a 1. There's got to be a 1 by X-wing somewhere up there. Okay, that's not interesting. Okay, well, thinking about 3 there led to this being either a 5-8 pair or a 6-9 pair. Thinking about 3 here makes this 3-6-9. Oh, that's always a 4, is it? If this goes 7-1-8, yeah, this is always a 4, this digit. Here's news. This is big news. Right, if this is a 3, this goes 3-6-9 and that digit is a 4. If this is a 7, this goes 7-1-8 and that's a 4, and then by Sudoku that's a 4. That is all, this one is always a 4. And that makes this one a 4, and that sorts this whole thing out, and I think we're going to finish now. That becomes an 8. 1, 3, 4 equals 8. 62 minutes before that breakthrough, and I mean, it might have been very available before, but this puzzle has cranked me up a bit. Now, that's an 8, that's a 1. Things are just filling in. It's so peculiar. No, not 2-5. 5-8 as a pair, and that not quite as helpful as I thought. So calm down with the things are filling in nonsense. These reds are 2s. These greens are 3s. I mean, they are filling in. I think we've nearly done all the primes, apart from columns 1, 7, 8 and 9. We've done a lot of them anyway. We've done a lot. And we're just taking it easy and calm and not panicking. These digits are from 2, 5, 6, 8. That's all we've got left in the row. Up here, that is a 6. This is a 7. That's a prime blue digit. These don't have a 9 in, so that's a 9 in the central box. This digit is known, it's a 6. This is not 6 or 8. None of them are 8. This digit is known, it's a 4. Why won't that sort out this row? Or will it? And I can't work it out. 5, 3, 4, 7. That's either 1, 2 or 2, 8. Making that either 1 or 6, 8 or 9. Brr. Not the amount of... Oh, 7, 7. That's a 7. That's all the 7s done. Who thought 7s were going to come up good in this? Not me. I've still got 2 arrows left to do and 2 prime cells. So peculiar when it all felt like it was over a moment ago. Now, these are from 4, 5, 9. That is 5 or 9. This is 4, 5 or 9. This one, 4, 7, 5, 3, I don't know. That's a 5 X-wing. 5s in rows 5 and 9 are confined to the final 2 columns. So these can't have a 5 in. There is a 5 in one of those 2 cells instead. Now this is getting a bit restrained. That's definitely even. So these 2 are the same parity. Haven't really thought about parity, but in this row, the things we have left are 3, 5, 8 and 9. Well, we can't have 8, or we'd have it with an odd number. So that's not 8. These are both odd. They're from 3, 5 and 9. And this, as the difference, is it's not 8, it's 2 or 6 now. This is 3 or 5. Suddenly parity, when everything in this puzzle has been primality or not. Now it's suddenly parity. There's a 5, 9 pair. We had a 5 X-wing. Neither of these can be 5. There we go. 9, 3, 6. Oh my goodness, this has been evil. That is 5 or 8. Let's get rid of the corner marks. Now, come on, down this column. That's a 1. And now we know the last arrow. It is 1, 1, 2. Isn't that fun? Well, I think it is. 5, 8, 2. The final column's done. That's a 5. This is 6 or 9. That is 6. That's 9. Okay. 1, 8. I can do these central rows now. They're finished. I can do rows 7 at least. Don't get ahead of yourself. These can't have an 8 in, and that can't have a 5 in. Top row 5, 8 pair. Next row 2, 5, 8 triple. 3, 7, 5, 9, 1. Oh, 9 is in this column already. Right. 4, 6, 8, 2. And that is going to clear up the whole sorry mess. Right. Let's get rid of the colouring. It's oh, don't restart the puzzle. Get rid of the colouring. That's what I was trying to do. There we go. And this is a 9. Wow, this has been another hour-long production from Cracking the Cryptic. But I've solved the puzzle and it's correct. And it's hard. Unlike yesterday when I knew it was hard, I don't know that about this puzzle. I don't think it is. I think I was slow, but we'll see from the comments. Thank you so much for sticking along and watching. Let's hope the camera is still going. And I'll see you again tomorrow. Bye for now.